In Chapter 10, we're going to talk about polynomial functions throughout the chapter and kind of things that go along with those, solving them, graphing them, and specifically in this lesson, you're going to learn about the zeros. And the zeros are really important. We've talked about these in Algebra 1 before, and we've talked about them this year. So zeros are really important because they tell us where the solutions are. So that's the first reason why they're important. They tell us where the solutions are. In calculus, they actually tell us where changes occur, and specifically later in this chapter, they're going to help us analyze and describe graphs. So they help us analyze and describe graphs. Specifically, something that we're going to talk about today is if f evaluated at some number c equals 0, then we say that that is a root or a zero or a solution. Is a root, a zero, or solution of f of x. Those three words are interchangeable, and you'll hear us use them throughout the videos, in class, and throughout all the lessons. So today's big thing is the factor theorem. The factor theorem tells us whether or not something is a factor of a polynomial. So it says, hey, if I take a factor x minus c, if it is a factor of a polynomial, then the remainder when I divide or synthetically divide by that number c should be 0. It is 0. So that's what it's saying here. In other words, if f of c equals 0, then x minus c is a factor of f of x. So today we're going to talk all about synthetic division. So it says, hey, use synthetic division to factor a polynomial. So the first thing is it's going to give you either a factor or it's going to give you a solution. You need to make sure that that factor is set equal to 0 so that you have x equals something. That value that x equals goes outside of your synthetic division. So then we actually go ahead and synthetically divide. So again, first set the factor equal to 0 if it's not already solved. Then we're going to start synthetic division. If the remainder equals 0, then it is a factor. So remainder 0 is a factor. If the remainder is not 0, then it's not a factor. And finally, if it is a factor, we need to check to see if we can factor the new polynomial that comes. So you're going to take that bottom line, so that comes from the bottom line of synthetic. So let's put this in use. The first thing that you're going to be asked to do is say, hey, determine whether it is a factor of the polynomial or not. So again, if I have a factor, I need to make sure it's equal to 0. So x plus 3 equals 0. Subtract 3 from both sides, x equals negative 3. That becomes what you synthetically divide by. So I take negative 3, and I set up the synthetic division. Now remember, in division, we put the coefficients of each variable in there. So first, you should look to see if any are missing. Here I have x squared, I have x, and I have 30. I don't have any missing. Remember that this is negative 1 here. So I've got negative 1, I've got 7, positive 7, and 30. So negative 1, positive 7, and 30. Drop down the 1. We end up with negative 1. Multiply in here, negative 3 times negative 1 is positive 3. Add together, we get 10. Multiply negative 3 by positive 10, you get negative 30. Add together, we have 0. Now, I'm done, so here is my remainder. Well, does my remainder equal 0? Yes, it is. So yes, x plus 3 is a factor of f of x. So again, now you can try this one on your own if you want, or keep listening to go through it. So set equal to 0. So let's take x plus 4 equals 0. So x equals negative 4. Now bring that down into my synthetic division. Negative 4. Now here's where you have to be careful. Again, going back here, we're missing some terms. So I always start by rewriting this as x cubed plus 0x squared. There is no x squared. Plus 0x. There is no x. Minus 27. So we decrease the degree by 1 each time. Now, I have a 1 out here. If there's nothing there, there's a 1. Got a 0, another 0, and a negative 27. So drop those into our synthetic division. So I've got 1, 0, 0, negative 27. Those zeros act as placeholders for me. Bring down 1. Negative 4 times 1, negative 4. Bring down negative 4. Negative 4 times negative 4 is 16. Bring down 16. Add together. Negative 4 times 16 is negative 64. Add those together. We end up with negative 91. Well, again, here we have negative 91. That's not equal to 0. So, x plus 4 is not a factor of f of x. Well, if it is a factor, we could go ahead and actually keep dividing here. I can take that bottom line and rewrite this as negative x plus 10 and set it equal to 0 to solve. So this is another factor of that polynomial. So that's what the next set actually asks us to do. So it says, hey, given that this value is a solution, factor it. Use factoring, the quadratic formula, completing the square, or even the even root property. One thing I will say is, hey, you might want to remember factoring by grouping. And we'll go through an example of how to do that as well. Remember the quadratic formula? That goes with our x squared, our ax squared plus bx plus c. Completing the square is not as common. An even root property, that's when you have just an x squared and no x. Alright, so let's go ahead and synthetically divide here. We always start with our synthetic division. Take 1/2. And here, look, do we have any missing terms? Cubed, squared, linear, and constant. So I need to take 12 plus 8 minus 13 plus 3. 12, 8, negative 13, and 3. Drop down 12. Multiply, we get 6. Add together, we end up getting to 14. Half of 14 is 7. Negative 13 plus 7. We end up with negative 6. Half of negative 6 is negative 3. And hey, that actually ends up being 0. It should be, because that's our remainder. So we're good. Now, again, this is where you take that bottom line, and we need to keep going further with it. We need to say, hey, this is really 12x squared, 1 less than the original power, plus 14x minus 6 equals 0. And now we need to factor that. Well, hopefully you see that there can be a 2 taken out of all of this. So let's divide out 2. Left with 6x squared plus 7x minus 3. And now we need to kind of keep going. Well, here's where you can take 2 routes. 1, we can factor this, or 2, because it's x squared, ax squared plus bx minus c, we can actually go ahead and use the quadratic formula. I'm going to go ahead and factor it because guessing and checking is not so difficult. So remember, we're looking to multiply to get 3 in the end, but we also need to get 6x squared somehow. So we need to set up two binomials to get us back to the one trinomial. So to get 6x, I'm going to try 3x and 2x. So 3x and 2x, to get negative 3, so I need to multiply to get negative 3, I need to use 1 and 3. Now I'll probably want a positive and a negative. I'm going to go ahead and try minus 1 and plus 3. Now here's where you can check this, because we're not all perfect, we don't get it right on the first time. Multiply the insides, you get negative 2x. Multiply the outsides, you get 9x. If you add those together, I get 7x. Well, that checks back with that 7x up there. It's positive. We're good. We factored it correctly. So right here, since this just asked me to factor it, that's my answer. If I were to solve it, I would keep going and set each of these equal to 0. But it just said factor. Alright, example 4. It tells us 1 is our solution, so take 1. That's what we start synthetically dividing by. Again, look to see if you missed anything. 3, 2, 1, nothing. So 4, negative 9, and 9. Bring down the 4. 1 times 4 is 4. We get 0. 1 times 0 is 0. Add them together, negative 9. Negative 9, we get 0. Again, it should be 0. We're good there. That's a remainder. And then make this again into an equation. Started with 3 power. Now we're down to 4x squared. There's no x, so I can just write minus 9 equals 0. So here you can go ahead, you could factor this, or we can go ahead and solve it too. If we needed to factor it, it's actually a perfect square factor. 2x squared minus 3 times, or 2x minus 3, 2x plus 3. I'm actually going to go ahead and solve this one so we can use the even root property. Since there's no middle term, add 9 to both sides. We end up getting 4x squared equals 9. Divide both sides by 4. X squared equals 9/4. And finally, when you take the square root of both sides, you get x equals plus or minus 3/2. Don't forget plus or minus whenever you take a square root. Again, if you were to factor this, 2x minus 3, 2x plus 3, because it's actually a perfect square binomial. Right? And the last one actually does say, hey, let's factor this completely, find the other zeros. Or, I'm sorry, this one says factor completely. These we're finding the zeros. So you should go back and find this. 2x plus 3 equals 0. So minus 3, 2x equals negative 3. Divide by 2, x equals negative 3/2. That's 1, 0. And again, take your other one. 3x minus 1 equals 0. Add 1, 3x equals 1. Divide by 3, x equals 1/3. Alright, and now let's do the one that just asks us to factor. So hopefully by now you're thinking, oh hey, I need to set that equal to 0. So x minus 2 equals 0. X equals positive 2 if you add 2 to both sides. So now synthetic division, so I'm using 2. And again, I'm looking back at my original problem. I've got a 4th power, 3rd power, 2nd power, linear, and constant. Nothing's missing, so I don't have to fill anything missing in. I have a 1, 3, 7, 15, and 10. Bring down your 1, multiply, get 2. We end up with 5. And then we multiply by 5, get 10. Here we get 17. Multiply by 2. we end up getting 34. Add them together, we actually get 49 multiplied by 2. Actually, I realize that this problem is not the one we intended. Your sheet is actually going to say x plus 2. So then if you solve x plus 2 equals 0, you get x equals negative 2. So that's how your problem should start. X plus 2 equals 0. Now, let's go ahead and factor that one off to the side here. So negative 2, go ahead, 1, 3, 7, 15, 10. Bring down the 1, negative 2. Add them together, positive 1. Minus 2, we get 5. 10, get 5 again, and negative 10, 0. Should realize that this other one wasn't actually going to end up being a solution. So it's good that we actually see how that would have went. So now, since I started with degree 4, this is actually going to be cubed. So x cubed plus x squared plus 5x plus 5. Now, whenever you end up with 4 terms, usually, but not always, you can group it. So look at this grouping here and this grouping here. Look at GCFs. Well, you should realize, hey, I can take out x squared here, and that leaves me with x plus 1. Because I take out squared, I am left with just x. Take out squared, you're left with 1. Here, you should see, oh, I can take out 5. I'm left with x plus 1. Now notice that these match each other now. That's the goal of factoring by grouping. So take your x plus 5 squared, x squared plus 5, put it together. That's because I'm factoring out an x plus 1. So you only write x plus 1 once. So both of those are factored. And now just bring down the original factor, which was actually x plus 2. So this is now factored completely, and if you wanted to solve it, you can set each equal to 0 and solve. But I'm not going to ask you to do that in this problem. Now, after watching this video, you should try these 3 on your own. These ones you just have to factor completely. This last one, you need to determine all the solutions possible.